on your WebAssign. It looks, I try to make it look like it, but I actually had a hard time. So the way it looks is you're given a rectangle, but you're not given a function like it. So this is number one off your WebAssign. And you have to, you're given that M and N are the same from that formula that I showed you, and they use the midpoint rule to estimate this interval. So you're using Riemann sums, just like you did with one dimension, you're doing it now with this kind of a problem. And you're supposed to also use the mean value theorem for intervals in the second part of the problem. That part is easy. The first part is a little bit tricky. So let me break this down step by step. With me? You guys are especially tired today. It's not my fault. You had a day off from me yesterday. What happened? We're not even at the end yet. We got one more day. All right, so I agree. It's a long week, but I'm always jazzed in here. That's the beauty of it. Like I come in here, I just like, oh, this is really cool stuff. So this is for your WebAssign. And you know how much we love these kind of problems where it might show up on quizzes and tests. We love these kind of problems. There's no function. We don't want to see if you understand what's going on. I'm guilty. I love those kind of problems. So step one is to cut the rectangle. Let's see. Into m by n, in this case 2 by 2 pieces. M is 2 and n is 2 is given to you in the problem. So my x's range between 0 to 8 and my y's range between 0 to 4. So my delta x is going to be 8 divided by 4, which is, actually, let me put this, the whole thing up, because you don't have to have it go by 0. It's going to be 8 minus 0 divided by 2. The 8 is the endpoint here. That's where that comes from. The 0 is the endpoint here. That's where that comes from. The 2 is the m value. Like that. Are you given the range? Yes, that's what's given to you. It's given to you exactly the way I've worded it here. A contour map is shown for the function on the square r equals blah, blah, blah. But what I'm telling you is it doesn't have to be 0 to 8, 0 to 4. It could be 2 to 8, and 6 to, or 3 to 4. Like, it doesn't have to be at the corner. So that's why I made all those little arrows. Find delta y. At your desk, find delta y. Actually, go to the board and find delta y. You guys need to stretch. Go to the board and find delta y. Let me pull this up. You'll be the first class to put the teacher to sleep. Come on.
Bottom says like m equals 2.
So now you have two axes. It's like you have not just an interval you're cutting up, you're cutting up the x-axis and the y-axis. And you're cutting up with equal numbers. So just like in Riemann sums, when you cut it up into 10 pieces, now you have two axes you have to cut up. They're both the same. We're just making it easy and saying just cut it up into 2 pieces. For you, yes. In this class, yes.
Okay, so.
But if you were actually doing a real problem, it's probably not to equal. Like if you had more stuff going on the y direction than the x direction, you might want to do an adaptive. But don't worry about it here.
What if it's since like I'm saying like m and n?
Yeah, you should have that, right? You might have to cut, like if you have more of like twisty things happening in one direction, you would want to have more chopping in specific parts. And they don't have to be all equal all the way through either. But don't worry about it. First, understand this. What'd you guys get? Delta Y is 2. Step 2. Is to find the 4 midpoints. How do I know there's 4? Because I have 4 boxes, 2 times 2. So on my little map, this is what it looks like. Here's my X, here's my Y. My X goes from 0 to 8. My Y goes from 0 to 4. I have chopped this thing into 4 boxes. Like that. This midpoint right here, what are the units? What are the coordinates for this? The 1. It's easy stuff. I made everything easy as I possibly could. Now take boards and find the other 3. Label it on the picture where they are. It's coming. Yeah. It represents how you sliced and diced the X and the Y axes. So I could have, for example, on the y-axis, I could have chosen my slicing of the y-axis to be 10 and the slicing of the x-axis to be 2. But for our class, we're going to keep them both the same.
Wait, does N represent all Y?
Yes, I think so.
Y comes to
Yes. I forget, but it doesn't matter because the M and N are going to be the same. I love that big graph in the back. It's better than anything I'm drawing. Then you can see it. You get me so far? Where everything's come from? Martin, you get it so far? Where would this midpoint be? Still 1 here, and it's going to be 6 because between 4 to 8 is 6 on the x-axis, and the y is still the same.
Oh, that's 4.
Where's the 4? Find the 4. Oh, 4. Y midpoints? Doesn't make sense. Okay. Step 3 is to estimate the height. This is why mathematicians put the z-axis the way we do. It's the height. We're thinking, take Riemann sums, everything's about calculus, go to 3 dimensions. F used to be the height on the old problems with 1 dimension. F should still be the height on the new stuff. That's the math way of thinking, right? The physics people are like, we're trying to solve problems, so we got a new dimension, it's going to come out into the front of us. The mathematicians are, we're trying to abstract problems. Whatever we did here, the generalization is to make height still height. So that's why we did what we did. Step 3. So your contour plot on your WebAssign is easy to look at. I tried to recreate this, and it's just really hard to draw. I drew this in Mathematica. It was hard for me to get the numbers to come right on the thing. So if I look at 2, 1, it's right here. And it's kind of in between this one, which has a height of 1, and this one, which has a height of 3. So this point, I could say, is approximately 3 plus 1 divided by 2, 4, 2. All right, go find the rest of them. Oh, yeah, you got to tell me. Math party. Yeah. So your contour plot, everything's labeled really nicely so that you can actually see like the curve. It'll say like 1 and 3 right here, but 2, 1 is right here. And it's in between this curve and this curve. This curve has height 1, this curve has height 3. Right, so that's how do it. So go find the other ones. I don't know if I'm looking in your ebook in the right place, but there was nothing like this as an example in the ebook. And when I saw it on the website, I'm like, yeah, I don't want to do this. Kind of a boring problem, but I pictured you sitting in the barracks cursing me out. But you shouldn't curse out loud, because whatever you do in the barrack room, you'll accidentally do in public. I told my sister that. I hope they never watch this. I told my sister that. She got in trouble at work saying a bad word. And I said, remember when Mom said not to ever say things out? I got hung up on. Wrong thing to say. In between contour lines, labeled 1 and 3. Did I misspell labels? I think I misspelled it. Labeled 1 and 3. See there's the labels on it? The one on your website is much more clean look.
And it's hard to like look at it. Like I need like my finger though.
I know. I think you might need a little bit of your finger to do it on the website. But it's better. It's like I was trying to get. I was rewriting the code for website. I go over and over just to get slickles on there. So there's a pain. And Dr. Groves is right next door to me, and I'm like, I had a hard time. I spent an hour trying to get this picture, and she goes, yeah, it's hard. And she walked off. I'm like, oh, that's great. That's nice. All right, take forwards and get the other midpoints, the other heights. Towards everyone. If you're confused, I come around. Who's confused? Even you look tired today. I just start to sleep badly by the end of the week because there's so much going on. I can't shut my mind off. And my dreams are boring. They're about work. So it's too much.
I usually find midpoint 6, 1 between 11 to 9. So you find the average. So like right here, this line's 11. This line is 9. So you're just taking the two lines. Like if you find the point that they're between the two contour lines, you're just taking that. Yeah, I just why. This V contour line is 8. You see how the contour line is 11? That's the value. So they have going from this center, it's increasing outwards. So that's the same line. So the line she's pointing at is 11. The one just inside of that is 9. And we're between those two. Right? So you take, you're in between 9 and you're in between 11. And there's 2 of them. So you can divide by 2 and you're estimating that you have 10. Anything that's between 9 and 11, you're fine. You do it.
Bothers me a little bit is your WebAssign. I'll show you your WebAssign problem. Why don't I show you a WebAssign problem? We'll finish this up. Did you break my chalk? Okay. You can take one of my chalk. That way I don't get mad at you.
It's easier for me.
All right. Who feels like they understand what's going on? Give me what you got. Oh, you can't see it? Everybody's coming to the front, just look at it. My problem is I go to the front, I go back to my desk, and I can't remember the numbers. I just looked at them. Oh. Which one are you looking at? 7, 13. I think I made this up. Tell me where you lost me. Oh, I was. You got it there. Understand it? Okay. 10 plus.
Wait, ma'am, I have a question. So, technically, the volume is.
We're getting there. We're getting there. We're not done yet. 6, 1, I bet. Something between 11 and 11. So I average blood on that.
Visualizing this correctly, so you have your x and your y values, and so you're finding these two, and then for volume you need the z value to multiply.
That is exactly the French fry sticks. Well, I have some faith I'm getting the same numbers. All right, take these. I'm gonna like. Do you want me to explain another one of where I came from? Confused. You guys understand it? Okay. Then you're gonna have to fill her in. I would just use 15 for 6-3 because that's the closest thing. That's the closest curve that I have information on. But it's 14, 15 is pretty close. All right, next step, step 4, apply midpoint rule. I gave them all the answers to the next, to the T while you were gone. Sophia. And they said they're not going to fill you in.
It's alright, I'll do it by myself. All right.
So this is, Chris, where you're like, oh, what each one of these has a base. The base, I know it's length times width. It's going to be 2 times 4 in our case. We get 8. And then the volume, the other part of it, is going to be the sum of all these guys. This is the Riemann sum. I think this is 10. And you got a calculator out. So just crunch that number out for me. And I hear the confusion about French fries. Where is that? What you're doing is, let's see, bring this up. You broke up the surface into little French fry sticks of equal length and width. And so you calculate the areas of all of these French fries at the bottom. That's your delta. And the heights are what's changing depending on where you're at. That's the labels on your contour plot. So the height of each of these changes depending on, I have 4 French fries in my little box. And all their heights are different. That's what you have there. 2 of the French fries are the same size and size 10. 1 of them size 15. So they're different heights. So you just compute the volume of every single one of those by taking the base times the length times width on the bottom times the height. That gives the volume of that. Well, the delta A is going to be the same for all, so you can just factor it out. So that's why the delta A comes out in front, which is 8, and this is the size of the heights of all those French fries, which is the volume. So what do we get for?
I got 296.
Okay, that's 296. The next question you have on your WebAssign is to find the average. That's kind of easy. What you do is you take the answer you get here, which is 296. Divided by the area, that's the normalization. It is exactly a z-score. So I love that you guys said that. It is a z-score. You're normalizing it. And we know now that's the mean value theorem for integrals. That's 296 divided by 8 times 4. The x length on your rectangle was 8. The y length was 4. The area of that whole rectangle is 8 times 4, which is 32. And so you get this answer. What do you get here?
I got 9.25.
Man, I thought 8 was the area of the rectangle.
8 is not the area of the rectangle. If you look at the problem statement, it's the rectangle's base is 8 and the height is 4. So from see the R definition here. So I try to make this look as exactly to what you have Let me see if I have it over here. It canceled me out.
Then before, why didn't you do 8 times 4 times?
Because those are the little French fries. The French fries are going to be 4 times 2. They're going to be 8. The bases are going to be 8 of the little, because you took the big rectangle, cut it up into 4 pieces.
Oh, okay.
Remember, you get 4 though. Why would it need to?
So the big rectangle looks like this. X goes from 0 to 8, Y goes from 0 to 4. The area of this rectangle, the total area of this rectangle is 32. But your little ones are not, right? The little ones, the area of this delta A, after you chop it, is going to be 4 times 2. Oh, yeah, it cut out for some reason.
What would the little ones?
There it is. The area of the whole thing is going to be 32. The area of the little one is going to be 8. And let me see if I can get this on.
Oh.
I don't have my glasses with me. Future. I can't show it to you because it shows the answer on it, but it's identical to what I just wrote out for you. Part 1 is to find the area from a contour plot. Part 2 is to know almost identical, except the picture's better. Like easier to read it. So everything's recorded. This should help you.